Welcome to today's edition of Science Half Hour. Today's subject is chemistry, and the topic of today is isotopes. Isotope is two or more atoms of the same element, which has the same atomic number with different mass numbers as a result of their differences in neutrons. Many students find it difficult to solve a problem based on isotopes because they don't know the right steps and process to take. Today you'll be listening the way to solve these isotopes and how you can be able to know different isotopes of the same element. It will start falling down. When the object starts falling down, then it means that the force of gravity has completely overcome the force of projection. The distance from here to here is the length, and distance from here to here is the height. The distance between here to here is the breadth. Sometimes many people are confused the difference between isotopes and the allotropy. The allotropy only discusses the physical properties of the same element, but they have different chemical properties. Isotopes only talks about the difference between their mass numbers of the same element, but they have the same atomic numbers. Examples of isotopes are isotopes of copper. Copper has two isotopes, 27% of 6529 and 73% of 6329. Isotopes of chlorine. Chlorine has two isotopes, 75 of chlorine 3517 and 25% of chlorine 3717. Iron has three isotopes, 5.8% of iron 5426, 91.6% of iron 5626, 2.2% of iron 5726, and 0.3% of iron 5826. Oxygen has two isotopes, 99.76% of oxygen 168, 0.04% of 178, and 0.2% of oxygen 188. Isotopes of magnesium. Magnesium has three isotopes, 78.6% of magnesium 2412, 10.1% of magnesium 2512, and 11.3% of magnesium 2612. Isotopes of carbon. Carbon has two isotopes, 98.9% of carbon 12-6 and 1.19% of carbon 13-6. Isotopes of zinc. Zinc has two isotopes, 25% of zinc 6430 and 75% of zinc 6630. Isotopes of lead. Lead has two isotopes, lead 20782 and lead 20882. Isotopes of hydrogen. Hydrogen has three isotopes. These are hydrogen 1, 1, hydrogen 2, 1, and hydrogen 3, 1. The hydrogen 1, 1 is called hydrogen or or protium. Hydrogen 2,1 is called heavy hydrogen or deuterium. Hydrogen 3,1 is called tritium or T. Representation of isotopes. Isotopes can be represented with symbols with the mass number and with the atomic numbers. If this is the symbol of the element, X represents the symbol of the element, and M represents the mass number, and A represents the atomic number of that element. Where X is the symbol, M is the mass number, A is the atomic number. From here, we calculate the abundant ratio of isotopes. How do we get the abundant ratio of isotopes? We get the abundance ratio of isotopes by dividing their percentages of those isotopes by the smallest. It will start falling down. When the object starts falling down, then it means that the force of gravity has completely overcome the force of projector. The distance from here to here is the length, and distance from here to here is the height. The distance between here to here is the breadth. So we talk about abundance ratio. The abundance ratio is got by dividing the percentages of those isotopes by the smallest. Examples. Calculate the ratio of each isotope in the following naturally occurring elements. When solving abundant ratio of isotopes, what we need to do is to use the percentages. When you're looking for the abundant ratio of the isotopes, you consider their percentages. We don't use the mass number, we don't use the atomic number. 63 is the mass number and 29 is the atomic number. And 65 is the mass number and 29 is the atomic number. The reason why this is called isotope is because this copper has two different mass numbers, 63 and 65. And it has the same atomic number, which is 29, atomic number 29, and this atomic number 29. Because of the differences in neutrons, that is why the mass numbers are also different. So, but they have the same atomic number. This is the reason why this is called isotopes. To solve for the abundant ratio, we use their percentages to get the abundant ratio. How do we get it? We divide the percentage by the smallest. Like this is 27% and this is the 73%. The smallest or the smaller among the two of them is 27. So abundant ratio of copper 63 29, and the copper 65, 29. The percentage of copper 63 is 27. Now say divide by the smallest ratio, by the smallest percentage, which is equals to 27 divided by 27 and 73 divided by 27. Does that give us 27 divided by 27 is 1. Is to 73 divided by 27 give us 3. So the answer gives us 1:3. So the abundant ratio of copper 63 and 65 is 1:3. Example 2. This is another example. Calculate the abundant ratio of 75% of chlorine 35 and 17 and 25% of chlorine 37, 17. So we are going to calculate the abundant ratio. Divide by the smallest. Between chlorine 35 and 17 and chlorine 37 and 17, the smallest percentage among them is 25. This 25 is smaller than 75, so we divide both sides by 25%. 75 over 25 is to 25 over 25. So we divide 75 by 25, then we also divide 25 by 25 because 25 is the smallest. The answer gives us 75 divided by 25 is 3, is to 25 divided by 25 gives us 1. So the abundant ratio of chlorine is 3:1. It will start falling down. When the object starts falling down, then it means that the force of gravity has completely overcome the force of projector. The distance from here to here is the length, and distance from here to here is the height. The distance between here to here is the breadth. Example 3. Calculate the abundant ratio of 78.6% of magnesium 2412, 10.1% of magnesium 2512, and 13.3% magnesium 2612. So magnesium has 3 isotopes. We divide the isotopes, their percentage by the smallest to get the abundant ratio. And the smallest among them here is 10.1%. 6 divided by 10.1. 10.1 divided by 10.1 is to 13.3 divided by 10.1. 78.6 divided by 10.1 give us 8 is to 10.1 divided by 10.1 give us 1 is to 13.3 divided by 10.1 give us 1. So the abundance ratio of magnesium, of isotopes of magnesium are 8:1 and 1. I believe you understood this topic. So I want to remind you again the definitions of isotopes. Isotopes is defined as two or more atoms of the same element which has different mass numbers but the same atomic numbers as a result of their differences in neutrons. The reason is that the neutrons are different. That is why their mass numbers are different. So I want you to subscribe to our YouTube channel. See you next time.